In this video, I will show you how to draw a mug with a handle. Tutorial by Vladimir London, a Life Drawing Academy tutor. At Life Drawing Academy, students from all over the world receive unlimited personal tutoring in the Correspondence Course. This course comes with 100 drawing tasks that range from such basic topics as how to sharpen and use a pencil, how to draw lines and geometric shapes, how to draw in perspective, how to render tonal values, to more advanced topics like how to draw portraits and figures, how to depict emotions in portraits, how to draw human bodies in motion, and so on. This drawing education is based on the most fundamental thing of realistic drawing, which is called constructive drawing. I'm flipping through pages of one of my sketchbooks just to show you a very small section of constructive drawing, how to intersect objects to find contours, which are virtual lines that reveal construction of three-dimensional objects. Although such exercises are optional for fine artists, they are very much needed for industrial designers and architects. Nevertheless, basic understanding of contours is also needed for visual artists who want to know how to draw any object from memory or imagination. In this tutorial, I will answer questions from Rose, one of the Correspondent Course students. She is now working on the topic of how to draw reclining cylindrical objects.
Hi Vladimir, I'm at the point in this cylinder where I need to decide how wide the back oval is going to be, and this is the model that I'm drawing. And if I hold my pencil up, let me just line it up and check, that front one is bigger than the back one, so that means that I need to make this back oval not quite as tall. Okay, so it's going to come to about here. But the question is that the way to work it out? Do you sort of just estimate it?
You can estimate dimensions, but measuring proportions from life is the better way.
For the cylinders, I think that this edge side, like the main axis of it, has to be longer than the axis running through the whole cylinder. Like here it's longer, but if these lines are obviously converging because of perspective, that's making this distance get shorter and shorter as you go up, which means that by the time we get over here, it's a lot shorter. And so if I have the same height oval but a shorter side, that means that the oval's height is going to be bigger than the width, which isn't what I want because then it won't look right.
You understand correctly that the cylinder's sides will converge towards the horizon, and therefore the back oval's width will be smaller than the front one. However, the dimension you are trying to guess will not be the same in both ovals. The best way to see it is to inscribe a cylinder into a cube.
For example, if I come over to these cylinders, which are correct because they were inscribed inside of a circle, I can see that this one here, for example, I've still got the lines where I drew it, by the way, but the long axis has a shorter amount than the main axis for each oval. And if I compare it to the back one, it does get slightly smaller because the center's there, but comparing that, it's slightly smaller. And if I compare the entire oval's long line axis length to the back one, can see that the back one is smaller. And that's a cylinder inscribed in a cube, so I know it's correct. So I know that it has to get slightly smaller, but I've also noticed that the ratio, in order to make this back circle oval appear fuller, the ratio has to change, because if I look at the smaller length and then compare it to the longer length, there's that much gap. So I know that on this back one, there has to be less of a gap and it has to get longer for this thing in relation to this. So if I measure here, I can see we've got that. And then if I compare it, there's a lot smaller of a gap. And then that's what makes the circle appear fuller, because eventually when you get straight on to a circle, all of the sides will be the same if it's a perfect circle, but obviously these are ovals, so they're seen in perspective.
Your observations are correct. I like your drawings of cubes with circles. By the way, what a great job! The front oval is bigger than the back one because it is closer to a viewer. Also, it always will be a bit slimmer, which you nicely depicted in your drawing.
Also, all of these cylinders were drawn from this same model, but it's amazing how different they look. Like, for example, that one to me does not look long enough, but I think that rather than it being a problem with it not being long enough, because I did measure it, I think the problem is that the angles of these sidelines are actually not steep enough, so it makes it look shorter, whereas I feel like if I'd made these angles go in more steeply, then it would have made it look like it was longer, but just seen in quite extreme perspective. But I don't know if that's correct, so I just wanted to ask you to get your feedback.
Yes, you are right. To make this cylinder appear longer, you need to draw vanishing lines at angles that converge more steeply to the horizon. To explain once again the points we covered so far, I will make a quick sketch of a reclining cylinder. The cylinder's axis is tilted, and two axes of ovals must be strictly perpendicular to the axis of the cylinder. This rule works no matter at what angle you see a cylinder. To make all lines clearly visible, I will draw in pen and ink. Drawing in ink is optional. I do it for demonstration purposes. Because ink is not erasable, I will use a pencil to mark faint lines before committing to ink. These ovals are symmetrical along the cylinder's axis. Two ovals have different proportions. The back oval is rounder than the front one. The front oval is bigger because it is closer to us. The oval's half that is closer to the viewer is slightly bigger than the other half. This rule is applicable to both front and back ovals. Keep in mind that circles in perspective always appear as perfect ellipses, but because their long axes do not go through the geometric center, we call such shapes ovals. In this drawing, you can see that the back oval is smaller and rounder, and the front one is bigger and slimmer. This is the case for all cylinders at any point of view. Also, we do not take absolute measurements from one oval to apply to another one. They have two different shapes. The sidelines of a horizontally reclining cylinder will converge and meet in the vanishing point somewhere on the horizon. Where this point is located is less important than the correct angle of those lines, which you can measure from life.
Hi again, Vladimir. I have a question about this mug that I'm drawing. So I've done the base ellipse shape for it, but I'm trying to add the handle now, and I drew it at the same angle, so parallel as these axes, but it just looked too steep. And also when I measure it from life, if I look at the angle that I think the handle's going at, it's like that, but when I compare it, it's much less steep than that. It's like that. So I'm just wondering, when you're drawing a handle on a cup that's reclining like that, does it have to be at the same, does it have to be parallel to these, or can it be at a slightly different angle like that, which is how it looks in real life? I'm drawing the mug for a second time because it didn't really work the first time. It didn't look that good because I didn't make the handle parallel to these main axes of the ovals. Because, I don't know, I was just doing it from life and I thought that it wasn't parallel, but I'm pretty sure it does have to be parallel, because otherwise that means that the handle is not actually, in line with the mug. It's actually off to the side. So I made it parallel, but I'm just making like a rough box of where the handle's going to be inscribed. Obviously starting here, I just wanted to do it from the center line to work out the thickness. But if I step back, there's something about that cuboid that just does not look right. And I'm making all the lines go straight down like in the cube drawings, but I don't know, part of me wants to make them go a bit more like this. Because it's a very quite harsh perspective, but I'm not going to do that because I'm not really sure whether that's right or not, because I still feel like it doesn't quite look like this mug that I'm trying to draw. I feel like there's something wrong with the handle, like it's at the wrong angle.
The handle's angle does not correlate to the angle of the oval's axis. It has to be measured separately. Also, a box that is not horizontal will not have its edges vertical. They will be tilted. I will draw a mug with the handle to explain. Because I draw from imagination, there is no mug to measure from life, so I will construct it. To begin with, let's draw a square prism that contains this cylinder. This prism will define the two-point perspective we see the cylinder in. As you can see, all horizontal lines of this prism are converging into two vanishing points somewhere beyond the drawing area. Nonetheless, these two virtual points are on the same horizon level. All vertical edges of this prism are depicted strictly vertically. I will draw two vertical lines through the centers of ovals. These lines will give the top and bottom points of the cylinder. Such points should be in the middle of the top and bottom edges of the prism. If this is not what you get, then the prism is distorted. As you can see, these points in my drawing are touching the square sides in the middle. Now, I will draw diagonals of two squares to check if they will cross in the center of each oval. In this drawing, they cross each other exactly in the center, which once again confirms that the prism is in the correct perspective. I will mark these centers with small circles. There is one more test to take. The horizontal lines through these centers should go through points where two ovals touch the squares exactly in the middle. I will mark these points in the middle with small circles. So we have a perfect prism in the correct perspective. At the top and bottom, the inscribed cylinder touches this prism. I will draw two lines where it happens. The bottom line is also the cylinder's footprint. Now, let's decide on the handle location. I mark 2 points to indicate its size. Through these points, I draw 2 vertical lines. At the bottom, these lines cross the footprint. I mark 2 points on the ground. At the top, there are also 2 points. We will use them later. I draw 2 lines in perspective through the footprint projection points. I know the correct angles of these lines because we already constructed the 2-point perspective. Now the interesting part, we need to find where the handle touches the ground. The handle has its thickness, which has to be accounted for. I will draw 3 lines from the ground to the central axis of the mug. You can see that the angle of these lines does not follow the main axis of the mug's oval. These 2 directions are independent of each other. Here are 2 points where the handle's box touches the ground. The line that goes from the ground aims slightly below the dot on the mug's axis. The second line goes through that dot, and the third line ends just above that dot. The distance between 2 lateral lines indicates the handle's thickness. Now, I will draw 2 more ovals at the top and bottom edges of the handle. The axes of these ovals will go through the dots on the mug's symmetry line. You can notice that each oval crosses the top and bottom points on the vertical axis. So, the oval is located between the lateral lines of the mug and also touches the ground. I will use 4 points circled here for drawing an ellipse. The same geometry is used to draw another oval at the opposite edge. Two ellipses at the top and bottom edges of the mug's handle are needed for a reason. They cross handle's lines in 2 key points. The line between these 2 points gives us the angle of the handle's box edge. I will draw this angle once again at another end. Now we can use that angle to draw the remaining edges of the box. I measure that angle with the pencil. As you appreciate, the short edges of the box are not estimated, but constructed with precision. There is no guesswork here, just constructive drawing. I will mark the remaining edges of the box. Here it is, constructed in perspective without any distortions. It is now easy to draw the actual handle inside this box. I draw it from imagination, but you can depict it from life by measuring angles and proportions. Here's one good tip: measure the negative space inside the handle as well. All that is left is to outline the mug in bolder lines. Because I draw in pen and ink, I cannot vary the darkness of lines, only their thickness. But if you draw in graphite pencil, make sure that lines that are closer to the viewer are bolder and darker than those lines that are further away. This is one of the main rules of aerial perspective, especially when you make wireframe drawings without tonal rendering. I hope you found this tutorial helpful in terms of how to draw a reclining cylinder, as well as how to draw a handle using constructive drawing principles. I made this video for Rose, who is now working on her 11th task in the Life Drawing Academy Correspondence Course. Imagine how much more Rose will learn by the time she completes all 100 drawing tasks. We guarantee that our students will achieve the advanced level of drawing skills should they follow the instructions and stick to the personal drawing curriculum that every student gets in this course. All tasks are well explained and illustrated. There are numerous videos for various drawing topics, and when needed, we can also make on-demand demonstrations like this one to explain difficult topics the easy way. That is why there is no way to fail in the Life Drawing Academy Correspondence Course. That is why every student who completes it will be able to draw whatever one sees or imagines on a professional level. If you would like to see what this course is about, check the video at lifedrawing.academy/correspondence-course. To find out what this academy is about, check its free video tutorials at lifedrawing.academy/free.